what problem are we solving? If you take your typical lab doing biomedical research, they probably document some of their research in Word documents. Doubtless they'll be using Excel spreadsheets. They tend to deal in a lot of images, so they probably got a lot of images that they're working with. Believe it or not, the dominant paradigm isn't even electronic, it's paper. So most labs are still using paper lab notebooks in addition to these other things. And then in some cases, they probably have some sequencing data, which could be out on a server somewhere. And it goes without saying, almost by just listing these things, that they're really not connected, which is in some way shocking, but it's true. This is in distinction to the pharmaceutical companies, which moved along even starting 30 years ago. But in terms of small biotechs and universities, this is what you see. So what happens? Well, data gets lost, data gets siloed, it's not shared, and it's not discoverable. So you can't have any big data if you can't access the data. That's one of the key things in our world anyway. So whose problem is this? Well, it's a problem for PhDs and postdocs because oftentimes they don't get credit for the work that they do because things get lost and there's not a proper record, there's not a proper audit trail. It's a problem for principal investigators because they find it hard to corral the work that people in the lab are doing. And there's the famous problem of the missing postdoc. What happens when the postdoc returns to their home country, takes their paper lab notebook or their computer and can't access the important research for the next paper? It's also a problem for both research institutions and biotech, so it's a problem at the organizational level as well. Because these days, institutions are under pressure from funders like the NHS to make available the data that's produced with publicly funded research, but you can't do that if you can't access it. And it's also a problem for funders and also for private funders as well. If you're an investor in an early stage biotech, something like a patent lawyer once told me that 50% of acquisitions of biotech companies fail because of inability to produce sufficient data. So we have a solution to this. As I said, it's a platform for managing biomedical research called RSpace. So what is RSpace? Well, I always find this hard to explain, but I think I'll three bites at the apple and see if any one of them works. On the one hand, it's an electronic lab notebook, so it's the electronic digital equivalent to what people do on paper. Another way to think of it is kind of like Google Docs for science. So it's collaborative software which is tailored for biomedical research contexts. And it's also a research platform, not just for labs, but for companies and institutions. Who uses RSpace? Labs in universities, medical schools, and research hospitals, so in nonprofit, in publicly funded contexts, and also labs in early stage biotechs. So what can you do with it? You can document your experiments. You can manage your protocols. It's got a lot of good support for image annotation, image management, because in biomedical area, this is something that's very important to people. You can manage and link to samples so that when you're using a sample, you're doing an experiment using a sample, you can link to the sample that was used in the experiment or the set of samples. Importantly, and this is something I'll talk a bit more about, you can also link to files, because too often other products in this space, they themselves become silos. So you can get data in to an electronic lab notebook, but what about the files? We said earlier, you often involves a lot of sequencing data. Well, the sequencing data is probably out on a server somewhere. There could be terabytes of it. You don't want to move that into your electronic notebook, but you do want to be able to link to it at the appropriate time to demonstrate what was done in your experiment. You can share data and collaborate. It's got protection for IP, so there's versioning, and there's a full audit trail, signing and witnessing. And importantly, it's also very easy to get data out. Again, this is kind of our anti-silo approach. And this relates to this point I was making in the cover slide about being an interface between little data and big data. So once you get the data in, which is already a big step forward as compared to paper, but we also have spent a lot of time making it possible to get data out. So this is a diagram which more or less instantiates the things which were on the previous slide. So RSpace, there's our software. People can enter data into it, manually enter data as they document their experiments. They can also link to file stores. They can link to whether it's a lab file store. Many institutions now have large file systems. You can link to the sequencing data or whatever it might be out on those systems. And you can also link to files that you keep. A lot of labs keep files on commercial offerings like Dropbox and Box. So there's one link, if you will, to big data. It's also very easy to get data out in a whole variety of formats, HTML, XML, Word, PDF, and it's extremely configurable, so you can export a single document, you can export everything in the system, everything that's a lab done. We have also done integrations with a number of popularly, commonly used repositories, which in turns allow data sharing because, as I said, the NIH, NSF, Wellcome Foundation in the UK, and all over the world, these funders are now requiring that data be made publicly available after it's done with publicly funded research. So the way that's being done is through these institutional and domain repositories, and we make it easy to get the data into those repositories. And likewise, it's easy to get data into archives, which is another, archiving is becoming much more important for public research institutions as well, because the regulations say you need to make the data publicly available, and you also need to preserve it. And finally, it's possible to get data from RSpace into other systems, other software, which could be important for collaboration. It could be important if your preclinical research is then going to be used in clinical research and it needs to go into another system. And finally, we just looking ahead into the future, a project we're working on at the moment, which we're quite excited about at Harvard Medical School. There's another local startup here called Starfish Storage, which is they would have been a great candidate to be here today. They have solved the problem of tracking files at scale. So if you're dealing with billions of files, they have a file tracking capability that can track the location. So when files move, links don't get broken. The launch customer for them is the Library of Congress, so you can see this as big institutions. And we are integrating RSpace with Starfish, and the first deployment is going to be at Harvard Medical School. So going back to the previous slide, we already have the ability to link files that are on external systems, which is a big step forward, but we still have the problem of broken file links. And with the Starfish integration, we'll be solving that. So that's going to be very exciting. So in sum, coming back to my opening remarks, we're a little data solution, helping at one level people to move from paper to going digital, and then to share the information and the data that they collect and that they generate. But also, because we support links to external file systems and data export to other systems, we also become an interface between little data and big data. Thank you.
Thank you, Rory.